let's talk about experiments. Sample surveys, which we've talked about before, try to estimate population parameters, like the height of Trinity students, whereas experiments try to assess the effects of treatments, like migraine medication. This is almost a direct quote from our book. For example, migraine headaches can be debilitating. If you know somebody who has migraines, you know what I'm talking about. Does the drug Maxalt relieve migraine headaches? How do we determine whether it works or not? Can we just give people Maxalt and see if they feel better? No. Believe it or not, sometimes people feel better when they take a pill, even if that pill has no medicine in it. Pills that have no medicine are called placebos. The placebo effect is an improvement in a person's condition that comes after taking a placebo, simply because the person believes that the placebo is real medicine and will be helpful. Instead of giving the medication to everybody and seeing how they feel, we need to randomly assign some people to receive the drug, this is the experimental group, and some people to receive a placebo, this is the control group. Then we see which group does better. Okay, so we don't want the subjects in the experiment to know whether they're getting the medicine or the placebo, because we want to avoid the placebo effect. Is it okay if the doctors who are interacting with the subjects know? No, because we don't want the doctors to unconsciously treat people differently. That's called the experimenter effect. We want the doctors and the subjects to be ignorant. Such an experiment is a double-blind experiment because both the doctors are blind and the subjects are blind. Nobody knows who's getting the medication and who's getting the placebo. For the sake of convenience, can we pick 100 people in Chicago to be the experimental group and 100 people in Phoenix to be the control group? No, people need to be assigned randomly. Otherwise, we don't know whether it's the drug or the Chicago weather that's producing the effect. The only difference in the way we treat the control group and the experimental group should be the medicine. It shouldn't be geography or who sends in the application first or anything else like that. Any other difference is called a confounding variable. There should only be one difference between the two groups, and that is one's group receiving the medication and one group's not. That's the only difference. Can we save money by picking only 20 people for the study? No, that's too small. Any positive results could be due to random chance. Clinical trials of drugs often involve several thousand people. It's good to start with a small pilot experiment involving 20 people. That's a great idea. But eventually, we will have to repeat it with a larger group. Suppose that in our large clinical trial, 30% of the control group see an improvement, but 30.1% of the experimental group see an improvement. Can we conclude that the treatment is effective? No. It's true that 30.1% is greater than 30%, but the difference is so small that it could be due to random chance. In such cases, we say that the difference is not statistically significant. Yes, 30.1 is greater than 30%, but it's not statistically significant. It could just be due to random chance. Suppose we randomly assign people to either a control group or an experimental group, and then find that one group is disproportionately male and the other group is disproportionately female. Or suppose we believe that a person's sex has a major impact on the effectiveness of the drug. How can we avoid this situation? By blocking. We group similar people into blocks, and then from each block we assign people to either a control group or an experimental group. Now this is not required. You don't have to do this in experiment. But what you could do, again, you have males, you have females, and then from the males you put people in control, put people in experimental. From females you put people in control, put people in experimental. Again, you don't need to do blocking, but you can do it. So here's what we do when we carry out an experiment. We state what we want to know. In this case, we want to know if Maxalt reduces the severity if it's taken by migraine sufferers when they're suffering a migraine. Specify the dependent variable, the response variable in other words, and how to measure it. Okay, in this case, the dependent variable is the severity of the migraine. So we might have a scale of, 0 to 10 or 0 to 5 or whatever. Specify the factor, the different treatments. In this case, the factor is the drug versus the placebo. Specify the experimental units. The subject you're experimenting on, those would be the people who are migraine sufferers. Okay, you want to reduce variability as much as possible. Ideally, the only difference between the people in the control group and the people in the experimental group is the people in the control group are receiving the placebo, the people in the experimental group are receiving the drug. You don't want the control group to be disproportionately wealthy or disproportionately male or disproportionately in the Midwest. You don't want that. You want to reduce any variability, reduce it as much as possible. You randomly assign subjects to groups, ideally groups that are large enough. You collect the results and graphically represent them. You know how to make box plots. And you compare the results and answer the question. Often a diagram of the experimental process is helpful. This is from our book, but it was developed by a guy named David Moore. Very nice statistician at Purdue University. You start with random allocation to group 1 and group 2. Group 1 receives treatment 1, group 2 receives treatment 2, and then you compare the results. By the way, how powerful is the placebo effect? In a study, researchers gave envelopes to migraine sufferers. The envelopes were labeled placebo or Maxalt, sometimes falsely. A placebo labeled as a placebo was not very effective. Amazingly, after 2 hours, a placebo falsely labeled as Maxalt was just as effective as Maxalt falsely labeled as a placebo. Now, after another half hour, Maxalt was more effective than placebo, regardless of the label. But still, it's amazing that when people think they're receiving medication, it really has an impact on them. That is the placebo effect.